Okay, so for this class, we are going to just learn about some of the most common synthetic polymers that we use in everyday lives and uh, learn a little bit more about recycling, actually. But let's look at those common synthetic polymers. So the first one is just polyethylene. It's the most simple. There, and to backtrack a bit, all of the common synthetic polymers are made from alkenes. That's where they start. They have alkene monomers that are reacted together to make polymers. So the first one is polyethylene. So this is the one we showed before. Its monomer unit is just a C2H4 unit shown in this box here. Where these are commonly used is things such as water bottles or bottles in general, the most common plastic that you'd see. Other synthetic polymers, we have polyvinyl chloride. So vinyl chloride is this molecule here. It's a name that we're not familiar with, but it's a name. That is the name of the molecule, but we could also call it 1-chloroethene. But for the purposes of the actual name, since this is the common name, polyvinyl chloride is uh, the name for this, and that this is what the molecule looks like. And then you'll see that we connect the same molecule. So in this box here, you see that you have C2H3Cl is your monomer unit, and they're connected into the polymer. PVC, or polyvinyl chloride, is used for things like PVC pipes, so plumbing pipes, things that you'd see at like Lowe's. Those are made of PVC, polyvinyl chloride. And then also saran wrap or like cling wrap is also PVC. Okay, so the third big synthetic polymer that we'll talk about is the polypropylene. So propylene is again a common name for this molecule here. So propylene is a propane. So really propene is what our name for it really would be. You can think of it as either, but propene units. So in each of these boxes, you see how there's the two carbons from the alkene, and then there's one methyl group hanging out for each monomer unit. So these are used for things like clothing. So for example, like hiking clothing or like sweat resistant clothing or water resistant clothing, things like that, or even they can be used in joints. So those of you going into physical therapy, that kind of field, or even the physical trainers, the medical grade joints that can be put into people's bodies are also could be made out of polypropylene. Two more, polytetrafluoroethylene. So tetrafluoroethylene or tetrafluoroethene is almost the same as our polyethylene, but it has tetrafluoro. That tetra meaning four. So each monomer unit has 4 fluorines on it. So our monomer unit is C2F4 instead of C2H4. Fluorines are interesting little boogers, and so they change properties a lot. And so this is commonly used, such as like nonstick coatings on pans are made out of polytetrafluoroethylene, which is also known as Teflon. Additionally, we have polydichloroethylene. So in this one, you can see we have on one side of our carbon, we have 2 chlorines, and on the other side, we have 2 hydrogens. So that means every other carbon in our polymer chain is going to have one carbon will have 2 hydrogens, and then the next carbon will have 2 chlorines. Go back and forth. Polydichloroethylene is like cling wrap, so saran wrap, plastics such as those. And then the last one is called polystyrene. So this molecule here, this molecule here is called styrene. So the aryl group, the phenyl group, or benzene group, and then a double bond off of it. That's called styrene, that particular unit or molecule. So polystyrene is these over and over and over. So this is probably the most complex in terms of drawing our polymer, what it's going to look like. And this is things like styrofoam. Styrofoam is polystyrene. So looking a little bit into some exciting uses for some polymers. So looking a little bit more into some exciting uses for polymers, or where else you might see some polymers other than these major synthetic ones we've talked about. First one is Kevlar. So this is a material used in a variety of different things, such as you can see on the side, as in fighter jets or body armor, or even in our phones. It's an incredibly strong polymer. So this molecule on the left here, you guys are not responsible for knowing this one. This is just for your knowledge and understanding. So we have this unit here. It will react, and it's not an alkene, it's a slightly different kind of polymer, but this will react and form super duper strong interactions within the chain itself, but it'll also form interactions with other chains nearby. Again, we don't need to know exactly what that is about. However, what is really cool is that the tensile strength. So this material is 5 times stronger than steel based off of an equal weight. So the same weight of Kevlar is 5 times stronger than that same weight of steel. So this is one example of when this was only discovered in 1965, and this is an example of a polymerization reaction that has been used to enhance technology in things such as fighter jets, or really enhance durability in this case. But having a really light material that's really strong can help, I guess, like the physics and engineering of making new things. Additionally, the science behind superglue is because of polymer chemistry. So superglue is actually not even really like normal glue. Normal glue, it's kind of these kind of sticky molecules that has a bunch of water in it. And when you let that glue dry, the water evaporates and those molecules are then more concentrated and they stick together better. Whereas superglue, it actually reacts and makes covalent bonds to each other. So, for example, these are the two common ones, cyanoacrylates, either methyl cyanoacrylate or ethyl cyanoacrylate, as it shows here. And these molecules, when a tiny, tiny bit of water is around them, they will interact with each other. So a tube of superglue is just pure amounts of one of the materials, whatever it is. And then when you use superglue, how it works over here is a super duper small amount of water. And it says even just the amount of water vapor in the air is enough to start this process. A small amount of water interacts with one molecule of the superglue, and that then interacts with another molecule and another molecule. So you're actually covalently bonding all of the molecules together just with a tiny bit of water. And that overall makes, ooh, I don't know how you guys aren't seeing this. Okay, it makes a polymer like this. Sorry, guys. So this is also pretty interesting. I didn't even think of this until pretty recently, but this is how superglue works, right? So this is why when you use a tube of superglue, you can't reuse it. It's kind of like one and done, right? If you open a tube of superglue, it's exposed to at least a small amount of water, and that can start the polymerization process and overall destroy the rest of your tube of superglue. So that's why typically superglue is a one and done. It's because it makes a big molecule. You can't, no matter how much water you put on it, it's not gonna to dilute that molecule anymore or dilute the solution anymore. It's already one big molecule. Okay, we're going to stop this video here and we'll do some practice and then talk about our last topic in the next video. See you guys there.